Welcome to Brain Vision.
We have the falcon's mass. Let's write down MF for falcon's mass. Well, falcon's mass is 600 gram, and 600 gram is equal to 0.60 kilogram, right? And the raven's mass is 1.5 kilogram. So raven's mass is equal to 1.5 kilogram. Well, let positive x-axis in the initial direction of the raven and plus y-axis in the initial direction of the falcon. So we have vf1x, right? So that's the initial speed of the falcon along x-axis is equal to 0. And then we have vr, and that's speed of raven, initial speed of raven along x-axis, right? That is equal to 9.00 meter per second. And also we have vf2x, right? Well, vf2x is 0. And in the y direction, we have vf1y. Well, vf1y is equal to 20.0 meter per second. And vr1y is equal to 0. And then we have vf2y, that is equal to minus 5.0 meter per second. All right. Well, now from collisions, right, we know that since there is no external net force on the system, the total momentum before the collision equals the total momentum after the collision. Therefore, total initial momentum is equal to total final momentum. P1 is equal to P2. Well, if the collision is between two particles, let's say A and B, then this equation can be written as initial momentum of particle A plus initial momentum of particle B is equal to final momentum of particle A plus final momentum of particle B, right? Okay, and we know that momentum is a product of mass and velocity vector. And we can write the collision equation in the following form: ma times va1 plus mass of b times vb1 is equal to mass of a times va2, right? Plus mass of b times vb2. Well, let's call this equation number 1, right? Well, for two-dimensional motion, we have ma va1x, right? va1x plus mb times vb1x. Well, that is equal to ma times va2x plus mb times vb2x, right? Well, let's call equation 2a, and also we have ma times va1y plus mb times vb1y is equal to ma va2y plus mb vb2y. Well, let's call this equation 2b. Well, now we do calculations, right? Well, the forces that the falcon and the raven are exerting on each other is large enough to ignore the effects of gravity and air resistance. Then there is no external net force on the system, so the momentum of the system is conserved. Now we plug our values for mass of falcon, mass of raven. Vf1x, Vr1x, and Vf2x in equation 2a. So plugging values in equation 2a, we have 0.6 times 0 plus 1.5, 1.5 times 9.0, right? And that is equal to 0.6 into 0 plus 1.5 times Vr2x. So Vr2x is equal to 9.0 meter per second. And similarly, we plug values into equation 2b, right? Then we have 0.6 into 20.0 plus 1.5, 1.5 into 0 is equal to 0.6 into minus 5.0 plus 1.5 times Vr2y, and solving for Vr2y, so Vr2y is equal to 10 meter per second. Right, now let's do part A. Well, we know that theta is equal to tan inverse of Vr2y divided by Vr2x, and this is equal to tan inverse into 10 divided by 9.0. Well, that is equal to 48.0 degrees, right? So the falcon changes the direction of the raven's motion by an angle 48.0 degrees. Now let's do part B. Well, the magnitude of the raven's velocity after the collision is given by, so Vr2 is equal to root Vr2x whole square plus Vr2y whole square. And now let's plug in values. 9.0 square plus 10 square, so that is equal to 13.45 meter per second.